Ready? Number one was the problem I was talking about. You're gonna have one of these. It says use the formula. This is the only time that the test is gonna require the limit rule for derivatives. So in this question, they gave us a g function equal to this guy. So then what you're gonna have to do is do the x plus h. So step one, do g of x plus h, which will be this guy. Step two is just subtract the f, or in this case, g. So do g of x plus h minus g. Just do a piece at a time. This will require you to do LCD stuff. Do it over here. Oops. LCD will be just these two are prime, so just multiply them together. So this will need an x plus 5. This will need x plus h plus 5. Let's see what I mean.
Mhm.
So that'll give us this garbage on top over this weird garbage on bottom. At this point, you're cool if I write LCD for this. Don't have to keep writing that. That makes sense.
Yes.
Okay, so multiply this garbage on the top and you'll get x squared plus 5x plus xh plus 5h minus this garbage. So that'll be x squared plus xh plus 5x. I'm gonna go ahead and move it over here because that looks weird. Okay. So then subtract these two. So the sign will swap all these. Okay. So notice the x squared, the 5x, and the xh will all cancel. Leaving you with 5h over this LCD. Okay. So I'll do step 3 on the next page. You cool with this? All these steps here?
Yes.
Okay. Okay. Cool. Turn the page.
Got a hitch. We can go to the next page.
Okay. So we have 5h over x plus 5 plus h, right?
Yeah, it's x plus h plus 5 and multiplied by x plus 5, I think.
Okay. So step 3, just go ahead and divide by h.
Your camera's a little out of focus.
Oops.
There we go. Thank you.
Okay. So basically that means you can also just think of this as multiplying, right, by 1 over h. Do you agree?
Yes.
So we can just cancel. Right?
Yes.
Step 4, just go ahead and take the limit at this point. So the limit as h goes to 0 of 5 over x plus 5 plus h times x plus 5 will be 5 over x plus 5 times x plus 5. And that's it. If you want to do more steps at once, you can. But overall, is it okay?
Yes, it is.
All right. So let me show you the exam. Just the review. So first one will be like this. You have something similar on your exam. Question 2, find the slope at this point, right? So all you gotta do is take a derivative and plug in x. So let's go ahead and do that. By the way, number 1 looks like it's gonna be A. I'm sorry, D. E. There's 6 options. Okay, number 2. Find the slope of the curve. at y equal to x squared plus 9x at x equal to -6. So all you got to do is take a derivative, which would be 2x plus 9. So the slope would be equal to the derivative at -6, which is 2 times -6 plus 9. What is that?
-3.
Yeah. Which is E. No, C.
Okay, so that one's pretty easy.
What's up?
And I was just like, that one was pretty easy.
Yeah, I mean, they're not all like number one.
2 whole pages.
Yeah.
I was like, oh, okay.
Yeah, it just starts off that way.
To intimidate us in a submission.
Yeah, just beats you down real quick and then shows out.
Get some humility.
But you're cool on two then?
Oh yeah. Are you kidding? That was like maybe half a page with like line spaces. I was cramming in the other one.
Yeah, that other one's, yeah. Number 3, find an equation for the tangent line on the curve at the given point. Oops. Okay. So basically you're going to use the formula y minus y1 equal to m times x minus x1. Except m would be equal to the derivative at 4. And this is your x1 and y1. Okay, so first thing we need is the derivative, then the derivative at 4. So m, I guess we call it m tangent, is equal to 8. X1 is 4. Y1 is 19. So just plug in the formula and we're pretty much done. Y minus 19 equals 8 times x minus 4. So that'll become 8x minus 32. Add your 19 over. What is that? This negative 32 plus 19. 13.
Yes.
Yeah. So this is A. So all you really needed was this fact and this fact here. Any questions on number 3?
Nope.
Okay. Number 4 is the same thing, so I'm going to move on. Let me show you. So 3, get an equation and a point. 4, equation and a point. It's just a different function.
Yeah.
5 says find the points where the graph of the function have horizontal tangents. So let's do that guy. Find the points where the graph have horizontal tangents. Okay. So what does it mean to have horizontal tangents? What does it mean for the derivative? Do you remember?
I remember it was like a solid number. Was it 1, 0?
Yeah, it's going to be 0. So the slopes at horizontal tangents are 0. So you use that fact to work backwards and find a point because we don't have any other information. So we're going to need the derivative. That's our derivative, right?
Yes.
Okay, so if they're curious about horizontal tangents, that means that the derivative is equal to 0. So solve for x. Divide by 3. Square root both sides, and you get plus or minus square root 7. So this is the x value that has a horizontal tangent. So that means the solution, the answer will have, right, my answer will have square root 7 for an x and negative square root 7 for the other x. So there's 2 locations. You can also graph this and you'll see them. But this is the work to show it, to find them. So plug in root 7 to get the y value. So root 7 times root 7 times root 7 is 7 root 7, right?
I don't remember.
Root 7 times root 7 is 7, correct? If you do it twice.
Yes. So then,
So if you do it one more time, it'd be this.
okay.
You see it?
Yeah. Roots always throw me off a little bit.
Oh, okay. This one here. So we have 7 root 7 minus 21 of them. So we can combine those, right?
Yes.
That would be 14 of them. Right?
Sounds right.
Sounds legit. Okay. Now let's plug in the negative. So that'll be root 7 cubed minus 21 times root 7. So that'll be 7 root 7 negative plus 21 root 7. So 21 minus 7, that's a positive 14 root 7. Any questions on the algebra, the calculus step, or the algebra part?
Nope.
So it looks like C is the answer. All right, 1 second.
Yeah, I finished writing it down.
Cool. Let's look at number 6 then. Six is very similar to 3. See how they gave us a point on number 3?
Yes.
On number 6, they just tell you the slope is 2. So basically they're telling you to set the derivative equal to 2 instead of this one, which was 0. They're kind of like giving you hints, like, all right, knowing the concept of derivatives, use that to set it to whatever they're talking about. Solve for, uh, here we solve for x and y. Over here, they want the equation of the line. Should have said tangent line here. Oh well. Find an equation of the tangent to the curve f of x equal to 2x squared minus 2x plus 1. That has a slope 2. So the derivative of f is equal to 4x minus 2. Set this guy to 2. Solve for x. Now use your formula, right? But we're going to need the y value. So
The y value is also 1.
is it?
Yeah.
Yeah, f of 1 will be 1. So we know that the point we need x1, y1 is here. So now we need the slope, which was given to us. All right. So just answer the question. Y minus y1 is equal to m times x minus x1. Y minus 1 is equal to 2 times x minus 2. So y is equal to 2x -3. Or is that wrong? Let me see.
You put 2 for x1 when it should be 1.
Oh yeah. Okay. Which is E. Not too bad, right?
Not too bad at all. And again, after that first one, these are reliefs.
Yeah, so you don't do the worst part first.
Right? It's like medicine.
Mm-hmm.
Hated taking steroids. They're so bitter. They're gross.
The pills just taste weird.
Well, they're bitter. Even the liquid form,
Mm.
it's like horrifically bitter and it stays with you for 10 minutes.
Yeah, that's hardcore.
Yeah.
Disgusting.
And it's really bad because the only times I need steroids are when I'm like really sick, and when I'm really sick, I'm nauseous. So
Ugh.
like a positive feedback loop of bad experiences.
Just gonna barf it out and have to start over.
Yeah. They're not cheap either.
Oh man.
Question 7.
So when you got sick, did you already have the vaccine or was it before?
I already had both the vaccines. I never got a booster, but I think it was within like 2, 3 months of getting the vaccine that I got sick. Yeah, I was also really stressed at the time though because my at that time my grandmother had just been in the hospital for I think a heart attack, and this was right before she would go back in to get a pacemaker. So I was just stressed out the wazoo. Because
Yeah.
which I think lowered my immune systems quite an amount.
Yeah, it's crazy how stress does that.
Which is a perfect storm of how to get me sick. Generally, I have the best immunity in my family because when I was young, I used to eat dog food.
Why?
Well, you live out in the country and your friends are the animals and all the dogs are eating dog food and you taste them and it's like, oh, it's like stale tortilla chips with a meaty flavor. And then my mom couldn't get me to stop eating the dog food, so she just switched to puppy chow.
Does that taste better?
No, it was just better for me. That's the funniest part of it. She just gave up and switched to puppy chow.
They give you a real nice coat.
Right? And hey, you know what? My hair's been growing fast, long, and slick ever since. So,
Oh man, that's hilarious. Start a trend.
oh no.
Those
Trends
weird
get started too easily nowadays. I don't want to add to it.
those weirdos on social media. You buy dog food for your hair.
They do it.
Yeah, I think so too.
I've already done so much stuff like just the onion water. And it's like, what do you think this is helping?
Gross. I haven't heard of that one. What the hell is that?
They just like chop up onions and put it in water and they're like, oh, it helps your digestion. Like, no, it doesn't.
They eat just the water or onions
Yeah,
and
they just drink the water with chopped up onion in it. It's like you're just making yourself have bad breath.
right? Does it just smell bad?
Or I think the root of it might have come from those like diet soups they would have. where it's like cabbage and onion, and it really just makes you lose all your water weight
Yeah.
because you're in the bathroom 24/7. So I think that's where they might have gotten the idea from, but it doesn't work that way. The main ingredient that works in those diet soups is the cabbage.
Ugh. They should just talk to their doctor like normal humans.
Why would they do that? Going to the doctor isn't trendy.
Suppose not. I don't have no space. Okay. So we're just doing the product rule. Okay.
Yep.
All right. They multiply everything out, so we're gonna have to distribute this guy will be 2. Yeah, I guess we'll do that. 2x times this entire thing minus 2 times that same thing plus 6x squared times that garbage. Excuse me. Minus 2x times that last piece. Okay. So distribute and we'll get 4x to the fourth minus 2x cubed plus 8x minus 4x cubed plus 2x squared minus 8 plus 12x to the fifth minus 6x to the fourth plus 24x squared. It doesn't fit right there. Minus 4x to the fourth minus or plus 2x third minus 8x. Okay. So these cancel. Thank God something does. Cubes cancel. Cool. 8x. All right. I think that's it. 24 and 2 combined. 12x to the fifth is left over. The next biggest, 6x to the fourth. Cube 2 and 2 squared. Okay. All right. Finally. Did I make a mistake?
It's not 26, it's 24.
24 plus 2, right?
Oh wait, no, never mind. Yeah.
There's no other fifth powers, right?
There's no other fifth that I can see.
Hmm. Okay, let me see what the answer is. Oh yeah, there. No. Looks like I screwed up somewhere. Huh. They don't have a fifth term.
Oh, hold on. I think you might have put g of x where f of x was supposed to go in that first line with it all put out.
Should be
Up one more. Yes. I think you put because that very last one
should
I
be F
think should be
prime.
the x squared minus 2x plus 2. So I think you arranged it in the wrong order.
Hold on.
Oh, you put it in there twice.
It's
That's
F
why.
prime G, right?
Yeah, so that one's right, but you put g in again instead of regular f.
Over here, I should have had G prime F. So this should have been F, right?
Yeah, that should have been f. That should have been the x squared 2x plus 2.
I see now. Okay. Darn it. Right at the beginning, too. I hate that.
That's the worst part. Especially with this, because then you can't just go up in the calculator.
Nah. Let me replace all that garbage. Okay. Good. All right. I think I fixed it.
Yeah, so it looks like it's going to be one of the two x to the fourth powers. But I don't know which one. Yeah.
Yeah. Okay. So 4 plus 6. This would be 10. Negative 2x cubed. Same garbage right there. Okay. So that'll be, let's double checking again. The only, oh, there's a cube here. 16, no. 18. Right? Negative 4. Negative 12 is 16.
I'm still working mine out. I'll get there in a second.
Ugh. They're getting negative 20x cubed. Did I write the question wrong? No. Well, my derivative is wrong.
Derivatives look right.
F prime G, G prime F. This is F, G prime, F prime, G. Yeah.
So I'm also getting the negative 20 x to the third.
You did get it?
Yes.
I don't know where I went wrong.
I think you might have crossed some out that weren't supposed to be crossed out because I have negative 2x to the third, negative 4x to the third, negative 12x to the third, and another negative 2x to the third. And they're all negative, all my thirds.
Yeah, I think I crossed it out last time and I forgot. So here they are. 2, 12 is 14, 16, 2, 4.
Or maybe it's 8. No?
18, 20. Yeah, yeah.
Yeah, 20. Okay.
The x squared, did you get 18? It's 2
Working on that right now. 2
plus 12, 14 plus 14. Yeah.
Yes, I am also getting 18.
Finally, Jesus Christ. Okay. All right.
Okay.
All right. Moving on. 8 is another product rule. Can you see number 8?
Yes.
All right. So you see how it's just 8x squared and EX. So two functions where we got to do product rule. Do you want to do this
Yeah.
one or do you see it?
How many questions are in this? Oh, 24. We can skip it.
Okay.
Because that one had some really good videos too going over that.
Number 9 has a quotient rule, and so is 10. Let's do 9, I guess. Find the derivative of using the quotient rule. Okay. I don't know why my paper looks like that. Weird. Um, and I'm just gonna call the top part f prime. G, I mean, this is not proper because I have two things being called G, but I hope that's cool.
Yeah. That's that's what I had, and I was like, you know what? I'll know.
All right. So I'm pretty sure. Let me double check myself. Pretty sure the derivative will be. I'm just gonna call this something else. It's just too weird. It's gonna be G prime times F. No, no.
Because it's f prime times g prime, or not g prime, regular g, and then minus the g prime times regular x prime.
Yeah, that's
I mean, not
right.
f prime. I keep saying prime, and I'm not meaning to.
It's okay. I'm sure we're both a bit tired. There you go.
Yes. Okay. Awesome.
Okay, so make some space for this. It'll be 2x times G minus 2x plus 6 times F x squared plus 6x squared. Okay.
Okay.
Distribute, we'll have 2x cubed plus 12x squared minus this result of 2x cubed plus 10x plus 6x squared plus 30. Right? Yeah. All right. That'll be minus 2x cubed minus 10x squared plus minus. All right, combine like terms and we're done. These are gone. 12 minus 10 is 2 minus 30. Cool.
Hold on. Why is your 10x squared?
For no magical reasons. I don't know. Who knows? Okay, so it'll be 12. And the only cube, well, the cubes do cancel. That was the only mistake, right?
And then shouldn't you still include the 6x squared?
Yeah, where'd that guy go? Weird.
Just kind of amalgamated them together.
Yes, so it's 12 plus 6. Negative 10. Plus 30. Looks like B.
Ruh-roh. Oh wait, no. No, I'm on the right one. Hmm. It's not showing one that has 18 on it, except for the one that says 4x to the third power.
Hmm. Let's see.
What are all your
Yeah,
options?
it should be minus. This should be 6. Man, make a lot of
Ah,
mistakes today.
yep.
Okay. 10 is easier and similar, so let's skip it. You cool on this page?
Yes.
Find y double prime given y equal to 6x sine x. So the first derivative will be a product rule, right?
Yep.
So derivative of this guy times this guy plus derivative of this one times that one, which will be this, right?
I think so.
My derivative of sine is cosine. Derivative of 6x is 6. And I just rearranged it. I'll do it again. They want double. Derivative of 6 sine will be 6 cosine. Derivative of this will be another product rule. So derivative of this times this plus derivative of this thing times 6x. So that will be 6 cosine plus 6 cosine minus 6x sine. Hopefully I didn't mess it up. Nope, looks like we're good. C.
So why does the 6x sine x keep that x right after the 6, but the 12 cosine x isn't 12x cosine x?
Which one?
The solution. Because like they were both multiplied by 6x, so why is it 6x sine x and not also 12x cosine x?
Well, this doesn't have an x, right?
Oh, I forgot. Yeah, it got cut out.
And then this derivative is 6.
Yeah, I forgot the derivative of the 6x.
Oh, okay. That's all good.
Trying to figure out. It's like, man, what's the difference? Well, one of them got derived.
Hmm.
Okay, I'm good now. The mystery is solved.
Cool. All right. Okay. So this will be a chain rule because of that function within a function. So derivative of q with respect to r would be, well, you got to change it to a half. Let me do that over here. To bring the half down. Subtract 1, that'll be negative half, times the derivative of the inside. This has a negative power on it, so just bring it down. Pretty much it. You change it, you can change it back to a square root if you want. That'll be 2 square root 17r minus r to the 5th. Does that make sense? The chain rule or any step that's
Yeah,
weird?
it does. Okay, got it.
Okay. The 13 and 14 are going to be product rules, or 13 is a product rule, but during the product, you can have a chain. 14 is the same thing. During a quotient, you're going to have a chain rule. Same with 15 and 16. Well, 16 is just straight up chain rule, actually. And then we get implicit. Okay, so let's see here. We are on Let's do 13. And then we'll skip 14, I guess.
Did you hear about Mitch McConnell?
Yeah. I'm trying really hard not to celebrate.
I'm not trying hard to not celebrate. Are you kidding? I ordered some Italian food.
Oh man. Do they still have a Democratic governor?
I have no idea because he's in Indiana, right?
Kentucky.
Close enough.
Yeah, they're all some sort of lame state. I don't remember. Let me see.
I tried to look at Mitch McConnell's state, and the first thing that shows up is Mitch McConnell stairs. Well, you can tell how the people are feeling. He's from Alabama.
So yeah, the Kentucky governor is a Democrat.
No, yeah, he represents Kentucky, but he was born in Alabama. Okay, got me for a sec.
He can, I think, I don't know if it's still true or if they changed it, but I think if Mitch can't keep going or dies, I think I think the governor gets to choose a replacement until it's time to vote again. Like
I'm
an
pretty sure that's right. I hope so.
like an interim kind of thing.
Yeah.
Uh, 'Cause I remember Mitch wanted to retire, but he didn't want to because he knew the governor would choose a replacement, and he wanted to change that rule before he left. I don't know if he ever did, but either way, I thought that was pretty scummy.
I hope he leaves tonight in one way or another.
Same man, guy's horrible. So I think I'm gonna be upset about those judges in the rest of my life, dude.
Yeah.
But I know he fell. Do you know what happened exactly or no?
He got a concussion from the fall because I think he was like on let it autocorrect the stairs because they don't give us all the information.
His stare?
Yeah, he he had some stairs
Oh,
for me and hospital.
thought you were cutting out there for a bit.
It was for his Senate leadership fund.
He did what?
He tripped and fell his own he tripped and felt his own Senate leadership fund. So
On
funny.
He fell on his own leadership fund?
He tripped and fell. Yeah, that was what the event was. It was like a campaign, part of his campaign committee
Oh, he
stuff.
was like, it was in public.
Yeah. And it was where it was at was formerly the Trump International Hotel. Oh, this is beautiful.
What's the name of the hotel you said?
It used to be the Trump International Hotel. Beautiful. It's all coming together.
It's like some QAnon shit.
Confession. Oh my God, he's had so many injuries. Like, why don't he just give up?
I don't know, man. Like, if I were,
Features.
if I had already made so much money off my position, I would just retire and, live life. Why the fuck are you still there at like 100 or however old he is? So I don't understand that. Okay. So here's a derivative. This chain rule doesn't really make a difference because derivative of the inside is 1. Derivative of this guy is going to be the chain. So you bring down the -3, subtract 1 times the derivative of the inside, which is 2x. So I guess we should say negative 6x times x squared plus 1 minus to the -4. Okay, so that'll be negative 6x times this garbage times f.
So hold on, why'd you change it from 3 to 6x in front of G prime?
No, this is -3 times that 2.
Okay.
Okay, so it'll be 2x plus 1 over x squared plus 1 cubed minus 6x times x plus 1 squared over x squared plus 1 to the 4th. Combine your fractions. So this one needs an LCD of x plus 1 to the 4th. Let's skip that step there. Hope that's cool.
Depends on if we get the right answer.
They both have x plus 1 in common and a 2 in common, so I'm going to pull that out, leaving me with x squared plus 1 minus 6x. Looks like I'm off by a little bit. Oh, yeah, yeah. Okay. Doing
Can you
this.
move the camera down a little bit? Awesome.
We're just doing some algebra now. So we got the LCD here. I factored this and 2 out of both there, leaving me with a 3 and one of these inside these parentheses. So multiply this out, gets me here. Plus 1 is from that one. The x squared minus 3, that'll be negative 2x squared minus 3x. Yeah, I don't know where the hell that plus 1 came from. Hold on a second.
Okay.
If I factor this out, I'd have this here. Pull out 2, have a 3. That's gone. So this will be a negative 3x squared minus 3x. Yeah, so it should be, I don't know where that minus 1 came from. That's the mistake. Okay. I'm trying to skip steps and I just confused myself. My bad. That's going to be D. If you factor a negative out of this, you'll get exactly what they have. All right, 14 and 15 are similar. It's just chain rules with products or quotient rules. Let's do 16 because that one looks like a multi-chain rule. That'll be better.
You said 16?
Yeah.
Okay.
All right. So dy dt will equal. So the outside most function or the outermost is that cube. So you first do the cube. So you bring down the 3, subtract 1, and then work your way in. So now times derivative of cosine of this. And put little quotes to make it a little easier. Times the derivative of the inside of that here. Unless I use brackets. Okay, so derivative of cosine. This part's already done. I did the power first. Pi t minus 12. Derivative of cosine is negative sine of pi t minus 12 times derivative of this, which will be just t. So final answer will be 3t negative cosine squared of pi t minus 12 times sine of pi t minus 12 . And that's it.
Okay.
That was like a double chain rule, I guess. You cool on 16?
What answer
Hmm?
is it?
Oh,
On the I'm not seeing who is the 3t.
oh, right. Derivative of this should be pi, not t. Right.
Yeah.
And that's another big pi. Okay, so implicit they want us to use implicit differentiation to find dy dx. So I'm going to take a derivative with respect to x of every term. So this will become 3x squared. This will become 6x, right? Product rule. Derivative of the first part times the second plus derivative of the second part, which is dy dx, times the first part. Derivative of this will be a power rule and then times the implicit piece. And you cool it up to that point.
Okay.
Okay. So just gather, move everything over that doesn't have a dy dx to the zero side, right hand side. Everything that does have a dy will stay right here. Factor dy dx. And divide. And you'll have this garbage. Here. Is that okay?
Yes.
Now you could reduce it by factoring 3 out. If I factor -3 and 3 out of the bottom, this will become xy plus x squared over x squared plus y squared. And this just cancels to a negative. You could distribute the negative back or leave it in front or put on the bottom. It doesn't matter. They left it in front.
Yes.
Made a slight mistake here. This should have a 2.
The little negative sign screws me out because it's so small on the answer choices. So I'm like, is that just a fleck on my screen or is it a whole different answer?
Hmm.
Depends on the day.
Yeah, it does look a little small. Okay. -19. Let's do the word problem. You cool on 17?
Yes. Oh, it says water. I thought it said Walter for a second. I was like, oh, poor Walter falling on the surface.
So water's falling on a surface, wetting a circular area that is expanding at a rate of 17 millimeters squared per second. Okay, so it's area. So area of a circle. I'm thinking I'm gonna need this, right? How fast is the radius of the wetted area expanding when the radius is 152 millimeters? Okay. All right. So the derivative of a with respect to time would equal to 2 pi r dr dt, right? They give us r to be 152. They give us dA dt, area of the disk or circular area increasing 7 millimeters per second squared. Find dr dt, it looks like, right? How fast is the radius expanding?
Yes.
So dr, if we solve for dr dt, that would simply be equal to 1 over 2 pi r times dA dt. So this will be 1 over 2 pi times 152 millimeters. Times 7 millimeters per second squared. Oh no, my bad. It's millimeters squared per second. This would cancel one of them, leaving me with 7 millimeters over 2 times pi times 152 per second. What the hell that is? Looks like it's roughly 0.0073 millimeters per second. This was given. They want this. Okay. Any questions on how we set it up and solved it?
Nope. Makes sense. Yeah.
Okay. My computer keeps lagging. Okay.
Yeah. It's been a wild day just around San Antonio and Floresville. Everyone's Wi-Fi is weird.
And there's supposed to be a storm coming, but I don't know if it's gonna happen. At least some rain, I guess.
Maybe around 5 a.m.
Yeah,
Like,
I think the forecast changed. It's supposed to rain like, when we got on for lecture. Anyway, 21 and 22 are just formulas, so follow the formula. Remember, I give you a list of inverse derivatives.
yes.
So see how you just plug it into that section, right? The argument goes in here. The top part is a chain rule. Third of the top, or the inside is 10x, right? The negative sign is coming from the formula. Same for sine. Use the formula, plug in this thing inside the argument, and that's it. The last one is Newton's method. We talked about that last time. Do you want to do 24, or did it make sense then?
Sure.
Okay.
Let's do a refresher.
All right. You cool on 19?
Yes.
So use Newton's method. It's 24. The last time we did the inverse trig formulas, and then we did Newton's method. I guess that was a week ago.
Yeah, I hope this rain doesn't knock out my internet again. We just got it fixed Monday or Tuesday.
Do you have another cow attack?
No, they have to, whenever the rain knocks around the stuff, they have to go to the box, like the shared box for the people around here and
Hmm.
fix something. It's just crazy. And it takes them forever to do it, especially because we're a less populated area, so they get less complaints if they take longer on us versus taking longer on another area.
That's annoying.
Yeah. But I was like, oh well.
Excuse me. Where is the
They
formula?
tried to keep charging us.
Try to what?
They keep trying to charge us for when it's out, and it's like, no. So we have to document it. So they give us refunds. It's ridiculous. Like, come
How
on.
long
What
is it?
happened to like business? Well, it goes out, I mean, fairly often because this is out in the middle of nowhere, so we tend to have more weather events and we are a lot more prone to suffering in those weather events. And then it takes them longer to fix it because again, small area. So if it had any more populous area first, I mean, well, it could be last, but they go there first.
I see. That sucks, man.
Benefits of living out in the country. There's no one to bother you, but you also can't bother too many other people.
Yeah, that's true. All right, -1 minus f of -1 over f prime of -1. So this is our starting point. So to find the next point, you use this formula. The formula says the next one is equal to the previous point minus the function at that previous over the derivative at that previous point. So we have f equal to this, derivative equal to this. So plug it in, then you'll get, let me make more space actually. All right, so I'm just using the formula. -1 into the original, -1 into the derivative. So that'd be -1 minus -1 minus 5 plus 2, 3 plus 5. Okay. I'm just going to go ahead and use the calculator. So this is -0.5. So there's x1. So now to find x2, you'll have to do x1 minus the function at x1 over the derivative at x1. So x1 would be -0.5 minus the function at negative 0.5. And with the derivative at negative 0.5. All right. So
Okay.
this will be a bunch of garbage.
You're so mean to these poor numbers.
All right. Whatever the hell that is. Let's see. I got negative 0.321. Did I mess up?
Or is it none of these?
It says it's A.
Which one is that on your screen? Because our
Was good.
letters get rearranged.
Oh, I missed a power here.
Ruh-roh.
There we go. We have to square this guy at the bottom on the calculator. Yeah, this is it. So we're just using the formula twice.
Looks good.
Any questions on any of the other problems?
Nope.
And then the rest doable?
Yes. Thank you.
All right. Now we'll wait to do more after spring break.
So when is the test due?
I'm gonna make it, if it's not already, it's gonna be due after spring break.
Okay. What are your plans for spring break?
I don't know yet. Hopefully rest, play some video games, visit some friends maybe. I don't
That's the life. There we go.
know. It's been a minute.
Yes, it has.
Not think about work. That's what I'm thinking about.
I would like to not think about work for one day.
Yeah, I'm just gonna pretend that I am a hobo.
Right?
That's the
Like,
life.
or pretend you're still a high schooler with stars in your eyes and nothing to do during the summer.
Yeah, those are the days. You'd spend
Right? Just run rampant.
crazy amount of hours just doing whatever you wanted.
Whatever you wanted. You could stay up all night and it didn't matter.
Didn't matter. Oh man, miss those days.
Yeah. Tell me about. Oh my God.
Maybe when we retire, we could do that again.
Yeah, when I retire, I'm probably going to be a substitute teacher and end up right back in there.
Yeah, in this shitty country, probably.
get that substitute money.
I don't think we'll have retirement of any kind.
Probably not.
Who knows?
You know what?